Hello calculus students. We are going to be talking about in this video the mean value theorem and Rolle's theorem, and then applying it on a couple problems. The mean value theorem basically states if f is continuous on a closed interval ab, these brackets here mean a closed interval, a and b are included in the interval, and differentiable on ab, open interval meaning that a and b are not included, then there exists at least one number, c, such that the derivative of f at c equals f of b minus f of a over b minus a. So basically what this is saying is, if you have a function, here's a function, and it's continuous. The green curve is continuous. It's between a and b. These are points a and b. So this point right here is point a comma f of a, and this point here is point b comma f of b. So what it's saying is, if you were to connect those dots, that dotted red line, that would give you a line, and the slope of that line is this. This is the definition of slope right here. The change in your y's, because this point right here is f of b minus f of a. Those are your y coordinates, okay? And a and b are your x coordinates. So basically you have 2 points. You've got a, and you've got f of a, and you've got b, and you've got f of b, and that's b f of b, and this is a f of a, and to find the slope, you would basically find the difference of your y coordinates and the difference of your x coordinates, and that would be the slope. So what the theorem says is, if it's continuous, if it's differentiable, then the slope that you have connecting those endpoints is going to exist somewhere at c as the slope of the tangent line to the curve. So here's c. So what it's saying is the derivative at c is going to be the same. This slope is going to be the same as this slope. That's what it's saying. Okay, that's simply all it's saying. Rolle's theorem just takes it one step forward. Actually, it's just Rolle's theorem is just a certain example that can happen with the mean value theorem. So what it's saying is, let's say f is continuous on a closed interval ab, too many f's there, and it's also differentiable on the open interval ab. And what happens if f of a equals f of b? Then there's at least one number c such that the derivative of f at c is 0. So it's just saying, and it makes sense, if this point and this point, okay, are equal, f of a, like this is f of a and f of b are the same thing, basically. If you connect the lines, the slope of that line is going to be 0. Okay, so the slope of the slope of the tangent line here at c is going to be 0. It's going to be 0. There's going to be a point somewhere where the slope is 0 in that continuous function. So let's see how we can apply this. Okay, I'm going to do an example for you. So you have a function, f of x equals x cubed plus 2x, on an interval between -1 and 1. This is our closed interval. First thing you have to check is it continuous? Is our function continuous? Well, this is just a polynomial. It's definitely continuous. There's nothing that would cause a break in that graph, anywhere on that graph. Is it differentiable? Yes, it's differentiable. Okay. There's no, there's not a place in between -1 and 1 where we have like some cusp or crazy undefined slope of a tangent line, and there's no place where we're going to have, a vertical tangent line. Okay, so those are check. Those are two things you have to check for before you can even apply the mean value theorem. Okay, so the mean value theorem does apply. So we're going to see if there's a point C that has the same slope as the slope between these 2 points. Okay, so the next thing you want to do is figure out what f of -1 is and f of 1. Okay, so f of -1 is, that would be 1 squared, -1 cubed, excuse me. So that's going to be -1, 2 times a -1. okay, which would give you a -1 plus a -2, which is a -3. And then f of 1 is going to be a 1 plus a 2 times 1, which is 3. Okay, so when we go to find our slope between these 2 points, we have to do f of b minus f of a. So that's going to be 3 minus a -3. Okay, over b minus a. This is b, this is a. So that's going to be 1 minus a -1. So this is going to be, the slope of this is going to be, this is going to be a 6. And this is going to be 2. So the slope of this is going to be 3. Okay, so now, last step. Okay, basically it's saying the slope between these 2 points in this interval, the endpoints of this interval, is 3. So that means when we find the derivatives, we find the derivative of this, which the derivative of this is 3x squared plus 2. Okay, so the derivative of this, here's our step 5 over here, has to be equal to 3, okay, for the mean value theorem to apply. So this is going to be 3x squared plus 2. Oops, sorry, that did not work very well. Okay, and then we solve this. We have to subtract 2 from both sides. We're going to get 1 equals 3x squared. So x is going to equal 1/3. X squared is going to equal 1/3. So x is going to equal plus or minus the square root of 1/3. Okay. And you have to double check and make sure that this point right here is actually in this interval, and it is. Okay, now I want you to try one. Okay, first you're going to have to decide if this is differentiable and continuous on the interval 0, 2. And if it is, then you're going to see if there's a value c such that the derivative at c equals the slope between these 2 endpoints of the interval. Go ahead and give that a try. Okay, so this is continuous. It's polynomial. Yes, it's continuous. It is differentiable, pretty much for the same reason. And then the next step you're going to do is you're going to figure out what f of 0 is, okay, which is just 0. If you plug 0 to the 4th minus 9 times 0, you're going to get 0. Then you're going to figure out f of 2. That is going to be 2 to the 4th minus 18, which is 16 minus 18, which would be -2. Then you're going to find the slope. So we're going to find the slope of those endpoints. So that is going to be a -2 minus 0 over 2 minus 0, which is a -1. Okay, so now we're going to find the derivative. It is 4x to the 3rd minus 9. And then we're going to set our derivative to -1 because we want a slope. We want to find out where c is, where the slope is -1. So that looks like this. So 4x cubed, we would add 9 to both sides, get an 8 here, divide both sides by 4, and get a 2 here. So x is going to equal the cube root of 2, or you could say x equals 2 to the 1/3 power. That is, and you have to check and make sure this number is in between. Your c has to be in between inside your interval, and it is. And that's all there is to it.